and let's get started. So, as I said, the title is somewhat a buzzword bingo, where AI, industrial IoT, so Internet of Things, consumer IoT, blockchain, decentralized identity, and edge computing meet. And cybernetics is really what I believe makes things move, enables a lot of things in digital transformation, from production to the impact of modern 5G-based infrastructures. And that is what I'd like to talk about in the next couple of minutes. So to get started, I want to quickly start with a little bit of a definition of cybernetics and make clear this is not something really entirely new. It's long available, it's widely used, but it's still trending, and it's probably maybe more trending than ever before. So these control circuits, which are behind cybernetics and that concept that has been established back in the 1940s, are the foundation for a wide range of things. And so I just picked a picture from the Wikipedia, which gives a little bit of a view on such a control circuit, which means you have input data, you get data back, and then it is checked and it might be adjusted and either given out to a system or again going into a feedback loop. So it's really this feedback loop thing which helps the system to continuously adjust and improve for what it needs to do. And this is basically the idea. And I think already that makes clear why things like IoT and AI, etc., are related, because it's about having a lot of input data, things, sensors deliver this data, and it's about understanding how to deal with the data, how to process the data, how to learn from the data, and that is where obviously AI can bring a value. So this is long available. So the term is said to be first being used by Plato, but the firmly establishment of the term happened in 1947 by Norbert Wiener, a scientist who's very much associated with the term of cybernetics. But again, concepts go back quite a while. So James Watt did things which could be mapped into the cybernetics theme, etc. It is widely used, and when you look at the areas of application of cybernetics, then this is in the computer science, such as in AI, such as in computer vision, control systems in manufacturing. That is where factually I learned first about it. I also learned about it, for instance, in certain management concepts. But you also find in robotics, biology, mathematics, etc. It's really a widely used concept at the end of the day. And I think from the sheer logic behind that, and when you dive a little deeper, for instance, also in the theory of cybernetics, you will find there are so many things, unless you anyway had it in one of your studies, which is pretty likely. And it's trending, and I think that's the point where really, as I've said, AI comes into play, where we see also more autonomous systems. Autonomous systems at the end of the day rely on that. They rely on this feedback loop, on the how can I get better, how can I control things. If you look at smart manufacturing, it's really ubiquitous, where you have immense amounts of data from sensors per second, hundreds of signals you receive. You need to process, you need to use to improve what you're doing. And so this is also where AI comes in, or connected vehicles. So it's even more relevant than it ever has been before. And it is tightly related with a number of these technologies we see that, so to speak, make the world move. So technologies that are of a specific relevance within digital transformation. And some of these technologies are AI, very clearly. So whatever we finally call AI, and that is subject to separate discussions. But technologies that help in augmenting users and automation in the autonomous systems, these are essential for many of the improvements we see in digital transformation. And that is about dealing with vast amounts of data, as I've already said, at high speed. And one of the areas where data comes from is from IoT devices, be it industrial IoT, such as in smart manufacturing, or be it consumer IoT. So all the devices you are using in your personal life. And we have billions of sensors and other things delivering data. So we're talking about huge numbers of things, also huge numbers of devices. And we're talking about incredible amounts of data that we can use for our control cycles, for our control circuits. And things must not go wrong here. So think about autonomous driving. That is something where these control circuits must work well, where we rely on that to really be successful. Then we have blockchain, which is not that much hype maybe anymore as it has been, but it is important for certain privacy use cases, for a secure and verifiable and integer storage of data in complex scenarios. So look at, for instance, IoT, which is a concept in the IoT space, which is some sort of distributed ledger, not exactly a blockchain. But these concepts are very hyped for a good reason when it comes to digital transformation use cases. And again, they play a role in that. Not the only one for storing data, for managing data, but an essential role because they enable us to do certain things better than without that. We have this theme of decentralized identity we at KuppingerCole are following since it exists, and where we also have our separate events on. But it's very obvious that when we have a world of things and devices and everyone owns many of these, we need identity concepts that work with all of these things seamlessly, not having the need to create one new identity per device or thing we are using. We need to make it better. So we need an autonomous identity in some way for our ubiquitous use across everything. Then there's edge computing. It's a little bit so this pendulum swinging back in cloud computing, saying we need to shift some workloads closer to the premises, for instance, around manufacturing, or we need to move certain things closer to the device and the thing when it's remotely. So when we deal with vehicles and other things, certain workloads must be processed very close to them. When we look at manufacturing, certain workloads must be very close to that. And so this is also a concept which helps us in dealing with certain of these changes and which plays into that because, again, it's not only relevant for IoT use cases, but for these it's of specific relevance. And again, so to make the world move, we need to look at edge computing and we need to look at 5G finally, be it in private 5G networks in certain manufacturing environments and fabrics, or be it 5G in the public, which enables to transport the data at the speed we need to have it transported. Because as I've again said, these control circuits need a lot of data. They need to process it very fast. And that also means the transport of data needs to be extremely fast. So these are the things which come together. And when we then look at, so to speak, our cybernetics control circuit at the center, how does this fit into all this? How does this play with all the other things? And then we have industrial IoT, for instance, a huge number of sensors, and we need to transport the data, which means we need 5G. We have blockchain or other types of ledgers which might be used then to store certain of the data or to deliver data. Again, this is in the play and it's required then again for input data for information to the control circuit or to the AI related to this entire thing. So this AI then again maps to 5G, it maps to our distributed ledgers, to our blockchains, whatever we have in use. And clearly it is the thing which helps in processing all the data for understanding what to change, so are we good or not? What do we need to adjust, etc. This is really what comes in. And the same is true for consumer IoT. So the data is processed and we might have some edge computing in between just for the sake of being fast enough in processing in workloads then. So this comes very frequently in that concept again. Again, blockchains, AI play a role, and specifically for consumer IoT, decentralized identities are super essential. So it is a complex scenario, and we need to understand that all these things are really tightly intertwined. So given that we have a focus on security, you probably expect me also to talk a little bit about security. I will want to do that relatively shortly, but I want to touch this topic. So what about security? And it is key to every solution because we can't let the circuit get out of control. It's nothing which it must not happen. And very clearly, the more elements we have, the more connected they are, the more they are at risk. And one thing I tell for years right now is there's a simple rule. Once you're connected, you are under attack. You must assume that once you put a system online, put something online, there will be automated attacks in a relatively short period of time starting. So we need to understand that these are under attack. And we also know, I think, from all the incidents we've seen over the past couple of years, that many of these systems are of specific interest for attackers. They are of interest because of industrial espionage, because of, in some way, more really conflicts between different states and other things. So there are so many scenarios where these models are at risk that we clearly need to look very roughly on that. And there are two parts of that story. One is security. We need to understand security. We need to ensure that results are valid, unbiased, reliable, and we need to implement adequate security and governance mechanisms for this entire environment. We can't do it for just a single piece. We need to do it more in a holistic manner. We need to understand how these things are related and what we need to do in security and governance across the entire solution. So everything which is in some way related to this cybernetics approach to the control circuit must be in focus. And the other element is safety. So safety is the other part, which means we must ensure that a car doesn't crash, that machines in a factory don't crash, that they don't go out of business. All these things related to safety are essential as well. And security and safety, the more you have connected systems, the closer they are related to each other. So we need to work hand in hand between operational technology, between the safety and between security here. So it is something we can't isolate anymore. It is an integrated play. And also there are some things to mention about identity. So there are so many identities right now, and we need to understand everything has an identity. We are talking not only about the human identities, we're talking about billions of identities of things, probably also billions of devices already. And we talk about complex relationships. So things are part of devices. If you look at a vehicle, pretty complex, you could say this is a big thing which consists of many small things. And then you have identities, and you have very complex relationships between that. So we need to understand that there's an identity of things. We need to deal with bigger numbers and these complex relationships. So for a vehicle, there's the owner, there's the garage, there's the driver, there are the people sitting in the car, there's the police. There are so many different organizations and individuals dealing with a complex set of things and devices. In the car, you have the entertainment, multimedia system, and other things. You have the engine and so many other elements, and all this is related. We need to understand this. We need to manage this. And when we go back to our picture from a few minutes ahead, then it means there are a lot of other things coming in. We have sensors. We have sensors in the consumer IoT, in 5G, in edge computing, blockchain, etc. They all can provide information about what is happening here. So we have information we can collect for security, we can use for security to understand how these things relate and how they work with each other. And we must do that. We must move to integrated security approaches. And we have the identity with sensors as well. So when is Martin authenticating or whatever? Another element here. So security and identity are related. And identity, again, is relevant for everything, for accessing the 5G network. There's the identity of the things. There's the identity of consumer IoT, things and devices, etc. And last but not least, there's governance. And governance then builds on security and on identity to really give us the insight about the risks, etc. This is what we need to do. And that then directly, so governance goes then back in some way to control, to adjust our systems. That brings me to our summary finally. And there are three things I'd like to give rephrase and re-emphasize. AI is essential for today's system, but it's not alone. We need to understand how AI maps to digital transformation, how it maps to cybernetics, and how it maps to a wide range of other technologies to make things work. These concepts are tightly intertwined. So without edge computing, without 5G or innovative ledgers, a lot of use cases will not work. And we need to do that then in a way where we add security, identity, governance across all of these systems. Because the more we have, the more complex our network is, the more it is at risk, the more risk of failure. And in the world we are talking about, failures can be very, very severe. So we need to really work on that beyond governance to a holistic concept. That is what we need to do. So rethink the way your solutions work. Cybernetics, control circles, AI, and more. That is what I'd like to give you today. Thank you for listening to me.